All right, good morning, everybody. My name is Kyle Houchins. I'm a tech and a trainer for McNeil, and this is Getting Started Rhino for Windows. If you haven't done any of my sessions before, I do them a little bit differently than most demos or software videos or whatever that you used to see. Basically, what I do is the day of or the night before, I do some kind of scrubby little sketch of an idea that I want to build, and then I put it away. I don't look at it again until it's go time, and then I break it out and try and reconcile with my life choices about what I'm going to do here. And I saw this, there's a garden center close to my house that my wife drags me to all the time. And I saw this watering can there that had this pattern on the side that I thought was cool. And I didn't necessarily like the details of the watering can, so I designed my own, but I did like the idea of the pattern on the side because I thought it brought up an interesting kind of workflow that I wanted to show. And so I did this little doodle and changed some of the stuff on it that I didn't like on theirs and came up with this thing. And don't look at the sketch too closely because it's a little scrubby. So we'll move it back here. That way you can't check out the details of it. But the thing that I wanted to talk about on this is basically this pattern and the complexity involved in getting this pattern repeated and getting the details all handled on that. And then a feature that a lot of people don't know about, which is merge all coplanar faces, which takes a complex thing, as long as it's planar, and turns it into a simpler thing, which is much easier to manage. So we're going to talk about that going forward. But as long as the video looks good and the audio looks good, I think we'll go ahead and jump in. The other thing that I wanted to mention is these sessions are interactive, so I do want you to hit the chat. If I do something that you need a little bit more explanation on, or you see something that you're like, what in the world? Hit the chat. I'll be more than happy to take a second and do a little side quest and talk a little bit more about that. But with that said, let's go ahead and jump in. And let's take a look at what we've got here. And so basically, this is a fairly square thing, right? The profile is pretty square. The body of this thing is fairly square. The profiles of each one of these little appendages, the handle and the spout, are also pretty square, which brings up a unique area, which is these blends. And something that Rhino gets criticized for quite a bit is filleting, and a lot of that criticism is deserved, but a considerable portion of it comes from, I'm trying to think about how to say this delicately because you don't want to do victim blaming here, but a lot of it comes from user error and not understanding kind of the rules of what you're trying to do. You can't put a giant fillet on a tiny radius. You can't put a small radius on top of a big radius. There's order that you have to do things. So we'll talk about that and hopefully give you some insight. And in fact, we probably won't end up using filleting at all. We'll probably end up doing some manual blending in here because of the complexity of how this works. So I'll show you how we'll crash the fillet tool into the wall, and I'll show you where the wheels on that fall off, and then we'll talk about what to do. The other thing about these sessions is because I haven't built this before, it's entirely possible I just shanked this right into the fan, make a mistake, and we have to stop, talk about what went wrong, and figure out how to fix it on the fly. And I actually don't mind that because there's a significant amount of learning that happens when you run into a situation like that in your own models, and you have to try and figure out like, okay, well, now what do I do? And the dedeline is a deadline for a reason, and you have to get there. So let's jump in and figure out this thing together and try and see what we can pull off in about an hour and a half, something like that. But any questions, hit the chat. Any questions before we get started? While we're going through the preliminaries here, I love if you don't mind, just hit the chat and let me know where you're from. It looks like we've got folks coming in from a long way, and I always enjoy kind of getting a picture of where everybody's coming in from. All right, so let's grab some coffee and let's go ahead and jump in. So the way that I always start these is essentially blank page, and we run the picture command, and I just find the sketch on my desktop. We drag it into the scene, and it comes in aspect ratio of the sketch, and if you need to change it, you can hold down the shift key, and that removes the aspect, but we're going to leave the aspect on and just drag it in like that. And I'm going to center this kind of origin-ish, and we're also going to kind of go, I'm going to scale this. This is about 8 inches across the bottom, more or less. And so what I'm going to do is I'm just going to draw a line that starts at 0. I'm going to give it 8 units, and then I'm going to just make a little hockey stick like that. And then what I'm going to do is run the scale command from 0, and then I'm going to scale this till it kind of lines up-ish in there, right? If you had to do something that was super precise, you would want to take the photos or the sketch or anything like that, and you would want to put some kind of scale in the image so that you could scale this once you got in here. So you'd want to like a 1 inch by 1 inch square on the sketch so that when you brought it in, or 10 millimeter by 10 millimeter, whatever you want to do, something that you can scale to specifically. But in this case, just something vague is kind of where we're aiming for. And if we throw a linear dimension on here, it should be in the vague neighborhood of 8-ish, which is fine. So we'll just go ahead and go with that. Now, building over this at full opacity is a little bit of a hassle. And so because when you draw lines, you can't see them. So I'm going to click on this. I'm going to look in my materials tab. And if you don't have a materials tab in the side, right click on any other tab, and it brings up a list of all of the other tabs that you can load. And go ahead and load your materials tab so you have it. In there, you'll see that there is a watering can sketch. I had 2 of them because I brought it in earlier, so I can actually delete this one. Don't need that one. But if you click on this, it brings up the properties for that particular material. And if you go down to the object transparency and crank this up, the image fades out a little bit. And that's kind of what we're looking for. The next thing that I like to do is I actually like to move this out of the modeling window. And the reason I do that is if we drop some geometry at 0 and we go into shaded mode, the model eats up the sketch. Whereas if I take this and I just slide it straight back in space, then I've got the sketch outside of the modeling window. I can still see it if I go to front view, everything lines up, but it's not, I don't lose the details of it along the way. So that's why I stick that back there. And then the very last thing I do is go to my layers tab. Oh, come on, Rhino. There we go. Go to my layers tab, and I'm going to create a new layer, and I'm just going to call this sketch, and I'm going to drop this here. I'm using a pre-production version of like 8.16 or something like that, and there's been some changes in the panels over here, so I'm hoping I haven't cursed myself by finding a bug live. But if we do, we'll stop and write it up. That'll be fabulous. All right, so let's go ahead, and I'm going to lock this image now, so this is on a layer that's locked. And we can go ahead and jump into the model now. So the first thing that I'm going to do, because this thing is basically square, I'm just going to use a cube. And I'm going to start with a cube. I'm going to drop it at 0, and I'm going to drag it out to be about the same size. And you know, because this sketch is kind of ish, I'm not gonna go crazy over, you know, every little last line. You can see that, you know, the edges aren't parallel, and you know, the shakiness of my hands and all that kind of stuff. And then we're going to go, I don't know, I'm going to go about 4 units wide. I think that probably is about right. And I might just use 4. And then I'm going to go to wireframe. And then we need to talk about like this as a unit, right? So this is a unit on itself. The spout is a unit about itself. The handle is a unit about itself. And we're going to build those all independently from each other so that we can adjust them and get it in a way that we're happy before we start doing the blending, right? That's kind of the process, is you want to work in chunks, I like to say, that everything is kind of self-contained and managed on its own. And then we worry about the transitions between, the objects themselves. So this would be considered, there's a bunch of different, kind of parlances for talking about this kind of stuff. And this would be the A object, and this would be, an A object, and this would be an A object, and the transitions would be the B surfaces and all that kind of stuff. You may hear, people talk about stuff like that. But for this particular case, let's just go ahead and talk about, kind of how we're going to get this thing the way we want it to be. And so the first kind of task is to establish kind of the radiuses of the edges of this thing. And there's a kind of almost like a little offset on this that it's almost like a chamfering kind of thing that's going on. And so we want to kind of figure out how to get all of that kind of dialed in. And so the first thing I'm going to do is let's just drop some radiuses on the edge of this thing. And I'm just going to go ahead and fillet the edges. And if we get those edges selected, actually, let's just use we'll use fillet edges here. So we're just going to click all 4 of these. And the preview, my screen is white and the previews on these are white, but if we go kind of something like that, and it looks like it is about 0.648, I'm gonna dial that in to 0.65, and then I'm gonna come up here to set all and do 0.65 for all of them, and then I'm gonna preview them just to see what they look like. And I think that that's probably what I'm looking for. Maybe a little bit bigger. Maybe we go 0.75 and see. Yeah, maybe even a little bigger. 1? Yeah, actually, 1 feels too much. And that gives us kind of our rounded suitcase start on this thing. Now, because we used 0.95, right? We can only use 0.949 or smaller on these edges. If I do 0.95, and I'm gonna check myself here and see if I'm being a liar, but if I run 0.95 on this again or 0.9 on this again, it is likely going to fail. Now, if I did this and did 0.95 on everything, it's going to work. And this is one of the things that makes everybody insane, right? They're like, well, why can it do one but not the other? And the only thing I've got for you is reasons. There's just reasons why it doesn't work. I can put you in touch with people who can explain the math behind this and why that doesn't work. But if I do 0.9 here, right, and I run that, and then I try to do 0.9 again here, it's going to fail. But if I do 0.89, maybe not quite enough, let's do 0.875, it works just fine. And it comes down to the ability for this thing to be able to wrap around the corner and have this inside corner not bow tie or be a singularity. And it's that singularity that causes the problem when you try to put a fillet on top of a fillet. And so the rule is you have to start big to small. So if you do 0.9 to start with, you have to go down to a smaller radius in order to do that. Or you have to do them all at the same time and let Rhino figure it out all at once. And it can handle that singularity when it does this because it puts this different type of surface in the edge here. Instead of actually tracking a surface around and actually having this be a pivot point, it actually puts a different type of surface in here, which is why this works and the other one doesn't. So for our purposes, I think what I want to do is I actually want to have the more traditional layout where this is 0.9, and let's do even like 0.75 on these, just to really end up with a nice clean. One of the things that I'm focused on is I want this surface here to be nice and clean because we're going to drop this pattern in it. And so I want this to be a planar surface that I can mess with, that has corners that are workable and all that kind of stuff. All right, so we're going to call that kind of good, and we're going to say that that's a good spot to start with. Now, there's a little filler in the top of here, and I'm going to just, as I'm apt to do when modeling, lie, cheat, and steal, and grab a copy of this, scale it down, and then I'm going to just add this to the top here, like that. And that way I know everything kind of lines up the way I want it to line up. And let's go to shaded view and see what we're doing. And that ends up being kind of what I'm looking for. And I don't think I want it to violate the edges. I don't think I want it to start peeling over, because what happens, see how this little swoop happens when you start going over an edge? And I'm looking at this little transition right there. I don't love that. So let's bring this just inside so it's right in the planar area, and then that way that intersection right there is nice and clean. And I may even do the same thing, moving it forward to get it out of the back of that, because I don't like how when this radius, there's a whole thing about like putting a radius on a radius and the shape that they make when they intersect, and I'm trying to mitigate that by just keeping all of this in the planar area. And then we may do some blending around here or something like that, but I'm going to just Boolean these together for now because it's easy, and that's the first two steps that we're going to deal with. Now, I'm going to save the handle and the spout for later because those are kind of the easiest parts of the whole model, but I want to talk about the pattern a little bit after I drink some coffee. Any questions so far? How many of you have beaten your head against filleting in Rhino and didn't know the start big to small rule and gotten bitten by it? There's a support group that'll meet after this in the lounge. All right, so I'm going to grab this surface, and I'm going to right click on the explode tool, which gives me an extract surface. And I'm not going to copy this, but I'm going to pull this surface out for the time being. And then I'm going to run the isolate command and hide everything except that. And we're going to talk about this embossed pattern. And I may have jumped the gun. I may not even want this out for the time being, but let's just leave it here as we find the way along the way. Now, we have to build the pattern, and the cell for this is, we have to kind of fit it within this area here. And so it's not quite lining up with my sketch because my sketch sucks, but that's neither here nor there at this point. So let's just kind of work with what we got. So I'm going to kind of pick this point as the center, and then I'm going to shift drag a center point curve straight out. And then I'm going to do the same thing over here, pick a point kind of in the center, and then shift drag. And that gives me, and I can even drop a point right here at this intersection if I turn my intersection snap on. And that gives us the center point of the reflection from one side to the other. And so what I can do is I can, make a symmetrical pattern, and we'll start with an ellipse, and I'm gonna kind of go from the center, and then I'm gonna drag this kind of straight out like that. And it's too big, but it's in the right orientation now, so I can shift scale and put it kind of where I want it to be. And then I'll move it kind of over there. And then we can mirror from the center. And then same thing down. And that's fairly okay-ish. Now, if we had done that with history, in fact, let's do that with history. I'm going to turn on history. And if I right-click, I want always record and update children. I want those on. And so let's mirror that that way, and then let's mirror that this way. Now, because this was the parent of this, and then these are the parents of that, I can take this and I can reorient my gumball, and I can change the aspect ratio of this, and it will update all 4 of them, which is nice because for, you know, especially for like pattern iteration and stuff like that, it's nice to be able to kind of see it all the way around and see what we're looking at. And if you don't know how I did that, if I double click on the rotate handle, it breaks the gumball free, and I can rotate it freely. And then I have an O snap set up here where I can snap that to this point, and that it doesn't really matter what the XYZ orientation is as long as it's oriented. One arrow's going this way and one arrow's going that way. So now I've got a scale handle where I can scale this right up and down the ellipse, and I've got another scale handle where I can scale it on the other, you know, axis of the ellipse, and then that way I can adjust these all the way I want them to be. And I think I want it a little fatter. Now, this shape in here is actually parallel to this guy down here. So I think what I'm going to do is I'm just going to copy paste, and then I'm going to shift drag, and I'm going to make this real big, and we can see how bad the sketch is. We'll all just ignore that, how bad this is. And then I'm going to mirror this across the center line. And I have a hotkey set up for mirroring. I apologize for hotkeys. It's not demo friendly, but here we are. I'll try and call it out. If I do something that looks like a magic trick and you're like, whoa, what was that? Call me out on it, and I'll make sure I let you know what key I'm using. All right. So this shape kind of comes in here and intersects with that, and then will come through here. Are those adjustments only available when you record history, or is that a gumball feature? So these adjustments are part of gumball, and the issue is, if you notice, let's isolate this. If you notice, because gumball is oriented XYZ, right, world, it doesn't have any relation to this. So if I tried to scale this, it's going to scale weird, right? That's not what we want. Now, if I shift drag, it's going to scale fine because we're doing a 3D scale. But if I try to 1D scale, it's not doing what I want. What I want to do is be able to scale in this direction. And so if I double click and break gumball free so that it's loose, then I can snap to this point, and now it's oriented in a way that makes a lot more sense, and I can scale it like this or like this, and that is much more useful. And so I use this all the time, this be able to relocate, rescale, you know, all that kind of stuff. And if you double click on the origin, it breaks the gumball loose, and you can move it to different spots. So if I wanted to rotate from this corner, so to speak, or if I wanted to scale from that corner, that's super useful. So double click at the origin to break it loose, and then, or double click any of the handles to break them loose. Now, if I double click a scale handle, it just allows me to move the scale handle. So if it's in a place that isn't useful, like it's right on top of a point or something like that, I can double click it, and then I can move those handles around. So it's one of the gumball superpowers. And there is a menu ball in here, which you can also get from down here. And reset gumball drops it right back in the XYZ origin. The other thing to point out is there are 2 settings for gumball. There's smooth dragging and snappy dragging. Smooth dragging does not respect O snaps, where snappy dragging does. So I run snappy dragging all the time. I was going to say almost always. I always run snappy dragging because it respects O snaps. And so that's the stuff over here. And I also run my O snaps disabled. You may notice that. The enable disable magic trick is just holding down the Alt key. So if I because these are disabled, even though gumball has snappy dragging, it's looking for an O snap, the O snaps are disabled. So if I double click this and I start rotating, it's not lighting anything up. Because the O snaps are disabled, there's nothing for it to snap to. However, if I hold down the Alt key, now it's finding O snaps, and I can do those. And I like that because with the O snaps enabled, if I enable these and I do that same thing, it's going snap, 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 snap. Settle down. Somebody had too much sugar cereal. Especially if you've got a lot of geometry on the screen. The snaps, it's like it'll give you a seizure because it's just like always looking for stuff. So I always shut that off. I was disable it and then just use the Alt key in order to enable it when I need it. And on the Mac, that's the Option key. Okay, so let's bring everything back for the time being. Just our curves. And let's finish up this pattern. And so we've got the basic shape in here, and I actually only want this little spot in the middle. So I'm actually going to run a tool called Curve Boolean. The command is called Curve Boolean. And I'm going to delete all of the inputs, and I'm just going to click right in there. And you can see that what it does is it intersects all of that and creates the piece that's left. So I can mirror this that way, and then I can rotate. I'm going to copy paste, and then I'm going to just rotate that with Gumball 90. And that gives us essentially our cell. Now, because I need to figure out how this thing goes together, and we can take a look at this and say, do we like this even, right? And I'm thinking, actually, I would like these to be bigger. I think that's betterer. Can I show Curve Boolean one more time? Yes. And my favorite demo for Curve Boolean is a gear. If you make a gear, and I don't know if you've ever tried to do this before, but if you try to make a gear, and I'll do a really simple one, transform array, polar, and we'll make 50 teeth. Too many teeth. Let's do 40 teeth. Still too many teeth. Let's do 30. Let's do 25. 25 teeth is what we're going to do. And if you had to do this the old way, right, you'd grab all this and you'd say trim, and you'd have to go trim, 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 mist, trim, mist, trim. Okay, make you crazy. Grab all this, Curve Boolean, delete input all, and I can either click outside, and what it's going to do is trace the outside of all of that, or I click inside, and it's going to trace the inside of it. And so what it's looking for is a closed boundary, and if I click outside, it's going to give me the boundary on the outside. Right click to accept, gear. I showed this to a company that did a lot of logo work, and they were bringing in all sorts of imported curves from Adobe Illustrator, and they were all really messy because they were all overlapping. And I asked them what their biggest pain point was, and they were like trimming these things out. And I was like, this is going to be a short class. I'm going to show you one command that's going to change your life, and you're going to pay me the money, and we're all going to go home. They were stoked. We covered a few other things, but that was pretty much the moneymaker for them. All right. So because this cell is going to be square, let's actually draw a square. So I'm going to click a point, I'm going to hold shift, and I'm going to just drag out a square, and that's going to establish the cell that we're going to work with. And I'm going to use Gumball, and I'm going to move it by this C-plane waffle, and then I'm going to just hold down Alt, and I'm going to snap that right to the center. Because Gumball's always at the bounding box center of whatever you draw, as long as this is square, then if I drop it at the center, it's going to be symmetrically arranged around all of this. And so if I shift drag, I can double check to make sure that all of my stuff fits inside the square, because that's how the cell is going to get enabled. Now, you can see one of the problems right now. You can see that like the apex of this thing is off, right? See how that's like not lined up correctly? So let's do a little, and you know, I'm sure there's somebody sitting there crossing their arms going, you could do this in Grasshopper and it would be perfect the first time. And I'm like, yes, you probably could, but I can't because I'm not Grasshopper-y. So I'm going to do this the old way, and I'm just going to move this up to here, and then I'm going to use the C-plane waffle, and I'm going to snap it right to the edge of that. And then I'm going to use the arrow, and I'm going to slide it right straight down there to get it to the orientation that I want. And you can see that that kind of fixes the misalignment of that cell. Now, I kind of want this cell to be spaced evenly. So I'm going to grab this and I'm going to scale this up a little bit until it kind of lands somewhere in the middle of about what my sketch looked like, right? So if I were to mirror around this point, we kind of want that spacing to be about there, and the size of this is going to determine kind of how that lands. And so I'm going to just do a couple experiments and figure out. I think that feels about right to me. So I'm going to call that about good. Now I'm going to drop a point in the center, but I am going to get rid of these just so I can visualize that better and figure out how this goes. Now, if this was perfectly square, we could lay this out and it would be, it would be the same number down, same number across, and all that kind of stuff, and everything would be great. Because it's like mildly rectangular, I think what I'm going to do is I'm just going to run the copy command, and I'm just going to copy from this point to that point, to that point, to that point, and then take a look at that and say, do I like that? And this is not part of the design, so I'm going to hide it and just double check and make sure that I feel good about that. As I may even shut my sketch off to see. That feels like that's reading okay to me. So now we can do the same thing. Let's bring those back. And I'm going to just run copy. And I'm going to copy from here to here to here to here to there. And that's essentially our pattern. Now, I'm going to bring back my surface, and I'm guessing, because the world is a cruel and unusual place, that this and these are not going to behave themselves in a way that I was expecting. So I have to try to get this kind of onto that. So I'm going to do cell CRV, cell curve, and I'm going to group these for the time being. And then I'm going to take my time and I'm going to just do a little lying, cheating, and stealing. And I'm going to move my gumball up to this corner, and I'm going to just scale it so that it fits there. And then I'm going to scale it so that it fits down here. And then what I want to do, because this is grouped and I know gumball is in the dead center of this object, I'm going to use gumball and I'm going to snap this to the center of that object in that direction. And then I'm going to do the same thing. I'm going to snap it to the center, the midpoint on the object in that direction. And now I know that this thing is like centered here, right? And that's great. Now, I think what I'm going to do is I'm going to make one complete unit out of this, and then I'm going to copy it throughout the entire thing. Instead of doing what your first inclination might be to do, which is to project all of these, split it, and then try and do it all at once. Because I think what I'd like to do is I'd like to have a little bit of filleting and some stuff on each one of these objects. And if I do it all at the same time, I'm going to have to fill it. That'll make us crazy. So I'm going to ungroup. And I'm going to ungroup that. And I know this fits now. So I'm going to actually select all of these, deselect one of them, and I'm going to delete the rest of them. And I'm going to get rid of those two. So I know that this is actually kind of what I'm looking for. And so what I'm going to do is I'm going to take this curve and I'm going to just snap it to this surface. And the reason I'm going to do that is because now I can use push-pull, and I can We'll do this in shaded mode because it's funner. I can select a surface to push pull. And I'm shift dragging or shift clicking. And then we're just going to stuff them in a little bit. And let's go about that far. And we're going to call that good. And then what I'm going to do, I might copy, actually before I do that, I might copy this surface just so I have it. I'm going to just copy it and leave it in the clipboard. And let's run push pull again. Shift clicking the spaces that I want to click. And I'm just going to right click, and that's going to drop it to the distance that I wanted it before. So now I'm going to trim everything else away. And then now that this is kind of one piece, we can go in and add our fillets. And so let's just fillet some edges in here. And we're going to do little teeny ones. And we'll start with one and kind of pick what one we want to use. 0.015. Let's do point. That looks like it's about right. So I said 0.125 and it rounded to 0.13. That's just the resolution of my dimensions. You can change that and have it actually display accurately, but that's probably plenty. So let's run on these guys. And let's try on these guys as well. I think that one should work there as well too. If I had rehearsed this, I would know, but I didn't. So we are going to figure it out along the way. And it looks like that's going to work fine. And again, I'm doing these all at the same time. If I was doing them one at a time, you're going to run into that problem where you're trying to stack a dimension that's the same size on top of another dimension, and it's going to make you sad. And then you're going to come on tech support, and then you're going to yell at me, and I'm going to be like, did you watch the water can video? And you're going to be like, no, I didn't want to watch water can video. I don't watch videos. I'm like, well, you should watch the video. Then you wouldn't be calling me on the phone being all mad. I think I said all that out loud. All right, so we've got our little bit here now, right? If we check that out, should be nice and done, right? And so now we simply just go back through the exact same process we did before. If we go back to shaded view, and we're just going to do our copies now. And we're going to copy from here to there, to there, to there. And then we're going to grab all of these and we're going to copy from here to here. And that's going to get all of those lined up the way that we want them to be, right? If we shade that, that should do its thing. If we grab this and join it, this should join everything. It's going to kill our history, but that's fine. If we look at show edges, it should only have a naked edge around the outside. That's what we want. Okay? If you've got naked edges, if you got pink on the inside when it's set to naked edges here, because this thing has an all edges or naked edges, if you do that, you're like, ah! It's all gone wrong. Nope, it's fine. Just make sure you're on naked edges instead. All right. And that tells you that everything internal on this is good. This is all watertight internally, and that's what you're kind of looking for. So if we bring this back and we bring this guy and this, we should be able to make a planar surface that fits in here. Now, remember we stashed that guy on the clipboard. So if I say Control V, it should actually bring that surface back, and it did. I'm going to isolate that. And then what I'm going to do is I'm going to run the trim command, and I'm going to use the curve switch, which a lot of people don't know. If I type CRV in the command line and hit enter, it's going to let me use surface edges as trim curves. And then what I can do is I can pick all of these guys. If I double click, it's going to grab all the ones that are tangent. And then I can trim out everything except that frame. Now, if I join this, you'll see it should only have a naked edge around the outside, which is what we wanted. Now, I talked before about merge all coplanar faces, and I'm going to save first because this is where I get bit when I don't. And then what I'm going to do is I'm going to run merge all coplanar faces, because right now if I look at this, right, this is a face, and 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 that's a lot of data that I may or may not need. Like if I wanted to do a transformation, or I wanted to do a cage edit or something like that, there's a lot of data to try and manage. So let's run this command called merge all coplanar faces. And what we're going to do is pick this guy, and it's going to think, but what it's going to do is it's going to go through and it's going to merge all of those individual faces into one trimmed face, keeping the fillets and all that kind of stuff, which makes this a much nicer thing, especially if you're going to do data transfer. If you're going to go to SolidWorks or UG or whatever you're going to do with it. And then we can, because this is symmetrical, delete that, mirror this along the midpoint. And if the world is a kind and just place, when I join it, it should be one closed poly surface, which it is. Boop. And if I look at show edges, there are no naked edges. So this is watertight, and we're good to go. And this is the crux. Like, we just pulled the hardest move of the whole climb here. This is the part that is the complicated part. Okay, so I'm going to save. And then let's talk about the next complicated part, which is how to take this stuff and merge it into this. And this, if I look at the sketch, it's indicating that this is kind of a rounded but squarish profile. And so I'm going to make my life super easy, and I'm going to do this first with just a dead straight line. And I'm going to take and I'm going to make a rounded square around a curve, and I can do this in perspective view. This is the curve. I'm going to snap it to the end. I'm going to hold down shift because that's going to constrain it. And then I'm going to pick, and then I'm going to drag out what my corners look like. Something like that. Now, that around curve is super useful because what it does is it actually puts it perpendicular to the curve, however it sits out. And the reason I'm doing this off of a straight line is because I want the simplest version of this surface to start with. This curve only has 2 points, which means this is going to be a degree 1 surface going in this direction, which is what I want. And then we're going to mess with it. So I'm going to take this and I'm going to isolate. And I'm going to copy this, and I'm going to move this down there. And then I'm going to adjust the scale of this thing. And again, I'm going to do that trick where I'm going to double click this, and I'm going to snap it to that edge because I want to scale it in this direction, and I want to scale it a little bit in that direction. And then we're going to do this whole thing with history so that we can play with it. And then all we're going to do is a single rail sweep. That's the rail. And we're going to just run that. We're going to do it freeform. We're not going to rebuild anything. We're going to say, okay. And what this does is this gives us a very, very simple version of this thing. And we can determine whether this is the right bigness or not, right? And because we are able to mess with this, then we can determine, you know, kind of how the flow of this is supposed to go and all that kind of stuff. Now, we can do a couple of things here. Because we did this with history, if I come in here and I pick this initial curve and I change its degree from 1 to 3, it's now going to give me some points in the center of that curve. Let's turn those on. I can mess with these now, and it's going to update the part. And as I move those, it's going to update that. Now, if I grab the original curve and the end of that point, I can use the arrow keys if they were set up correctly, which they're not. So let's do that. Let's do modeling aids, nudge, arrow keys. Fine. And now I can use the arrow keys and I can just nudge these around the way I want them to get it exactly kind of where I want this to land. And this is like super helpful for iteration because you can just kind of sneak up on it. And this thing needs to be bigger still. And maybe even rotated just a little bit. We'll call something like that. Maybe we'll fuss this one just a little bit more. And let's look at it and see what it looks like. Other than being in a completely wrong position, let's grab those curves using cell curve. Again, if we want to maintain history, we got to just work with the curves. So if I just move the curves around, then the surface is going to follow it along. And I think that that probably is pretty workable. It looks like our spout is flat instead of open like that. And so I probably what I'll end up doing is I'm going to just pull this a little bit past where the original design was so that we can cut it off. All right, so let's call that good. And I'm going to cap these and make them solid because that makes this really easy to just do a Boolean. And that joins up just fine. Now, here comes the fun part. If I run a fillet around this, I'm going to save. If I run a fillet around this, actually I'm going to use a blend. I'm going to right click on this tool. If you look underneath here, the left click is fillet, the right click is blend. I'm going to blend these. And the first thing you'll notice is that the preview is hooking over the edge of this. That's going to fail instantly. So I actually have to make this inside so that it's on the same surface. And if we preview this, it's going to probably make a giant mess. And the reason is because this fillet down here is way bigger than that fillet down there. So what we want to do is we're going to add some handles. And I'm going to add a handle kind of there. And I'm going to add another handle over here. And then I'm going to add another one kind of right there. And we're going to adjust these guys unless it dies. And it, believe it or not, it actually created a surface even though that's a disaster. So let's crank this one down pretty small. Let's go like 0.7. And let's take this one down as well. And we're actually kind of sneaking up on something that might get us home. But it's looking kind of like my confidence with this is not amazing, right? maybe we move where this handle is. Maybe we move this guy down to a similar area. But I'm kind of not loving that. I don't know if you guys are feeling that, but let's add a new handle. And that's going to make a mess. Let's take this down quite small. That is not awesome. I don't love that. So let's go a different way. Okay, this is a common place where people are just like, I give up. There's a thing called what I like to refer to as the pipe trim trick. And James Carruthers was the guy who taught me how to do this. If you don't know James, he's a longtime Rhino guy. And so what I'm going to do is I'm going to duplicate an edge, and I'm actually going to come down here. I'm going to create a pipe around this edge, and I'm going to let that run. And you'll notice that a couple of things. One, see how this pipe is self-intersecting? That gives you kind of a good indication that your pipe is too big. And so let's put a radius here, and then let's put a tiny radius up here. And I'm just kind of eyeballing this stuff. And then let's put another one that's closer to the first one here. And if I was paying attention, I would go through and actually, like, you know, pay attention to those actual diameters. But what you end up with is you end up with this, okay? And this object, and I probably should figure out how to get that. It'll be a little bit more symmetrical. But if I look at this and I do an intersection, right? It's going to give me two curves. And if I look at where this first curve is and this second curve, right? So the first curve is going to come vaguely through here. And it's a little bit ugly the way that works. So what if we made a little bit nicer version of that curve and we said, that's going to go kind of right there. And we'll project that on. Get rid of this one. And then we say, this curve, I don't really love the shape of that one. So let's see if we can fix that up a little bit. And maybe what we want to do is start with a center square. And we're going to kind of go midline on this thing. And we're going to do something kind of maybe like that. And then we're going to shift control drag this bottom part, scale that out, shift control click this one, scale it in a little bit. And then maybe what we'll do is come up here to, instead of using fillet, we're going to use a blend curve. And we're going to blend into these corners. I'm going to flip one so that we can end up with really nice curvature continuous corners. And I'm going to trim that. And I'm going to get rid of history because history is biting me at this point. So I'm going to shut that off. All right, and then I can mirror this. And we're going to end up with a nice trim curve. Okay. I'm going to shut the history break warning off because I don't care. I know, I'm doing it on purpose. Rhino's all like, don't forget to wear your coat. Yes, Mom, shut up. Not in front of the guys. Join all the, let's do a blend. Not there. There, flip 2. And I'm going to just eyeball this to make it a little nicer. And I'm going to trim it, but I'm not going to join it. And then I'm going to mirror this to the other side. And I'm going to delete this original curve. Join that all up, bring this back, and then I'm going to project this right onto the model. And then what that's going to do is that's going to give me 2 trim curves. And I can build a blend surface between this. So if I pick this curve, and then I trim, it gives me a gap. And the gap is what I wanted. So instead of modeling surfaces, I'm modeling a gap. Now I can come in with blend surf, and I can blend these 2 objects together. And I'm going to just do it tangency. I don't need to go crazy. And I'm going to add some shapes in here. And I'm going to add one kind of here to here. And you can see this is already starting to come together in a much nicer way than it did with the fillet tool. And now we've got a little bit of adjustment that we can do down here. And so you can see how it's kind of freaking out a little bit around that corner. So let's add a couple more handles down here. And now we can play with the actual blending on this. And we can say, does this come out a little bit? Maybe that pushes a little more. And you can see that that's actually traveling around pretty nicely. Now, I don't like the angle of this one, so I'm going to hold down the Alt key, and I'm actually going to change the angle of how that's coming off. See how that adjusted the isoparams a little bit? Same thing down here. Because my shape is kind of coming in this direction, but my blend is fighting it, so I'm going to actually make the blend respect more of that shape, and you can see that highlight changes and gets a little bit nicer. Maybe we aim for more of a center. Something like that. Maybe let's see what it looks like with curvature. Why not? Not so bad. So let's go okay. Let's join it up. The nice thing about this is it should join up nicely. And if we do a render view on that, that has blended in fairly nicely. And everything looks good in white, so let's throw a little color on it and see what it looks like. If anybody ever does a demo and they just show you a white model and they're like, look, I'm done. Liar. That looks pretty good. I'm pretty happy with that. That'll be all right. All right, we're going to do the same thing with this handle in here. And this is actually a fairly simple shape. So let's just go ahead and I am going to, looks like we've got a little curve here. So I'm going to draw this instead of constructing it, so to speak. And I'm going to follow rule of 3 pretty strictly here. And if you don't know what rule of 3 is, check out my rule of 3 video on YouTube. It basically states that it only takes 3 points to make a curve or a corner. No more, no less. And if we look at this, I've got a shape here, kind of a concave shape. So that's 1, 2, 3. I've got a corner here, which is 1, 2, 3. I've got a shape between these 3 points. So that's 1, 2, 3. I've got this transition, 1, 2, 3. I've got this shape, 1, 2, 3. And I could probably get away with maybe getting rid of that point, but I don't think so. This corner, 1, 2, 3, and then 1, 2, 3 here to make that shape here. And I always harp on this because it's important. Okay, because I always see people make corners like this. Right? No. 1, 2, 3. That's your corner. If you want it sharper, move the points closer. If you want it less sharper, move them farther apart. Okay? That's all it takes. If you keep that in mind when you're building stuff, especially if you're doing sub-D stuff, rule of 3 is massively important in sub-D. It'll make your life a lot easier. So I'm going to copy, paste that, and I'm going to scale it in so that my family of shapes is all behaving itself. And then let's turn the points on. And I'm going to slide these guys in a little bit. Do you know what I'm talking about when I say family of shape? There's like a kind of shapes that go together, and you want to make sure that they kind of respect each other's initial shape and all that kind of stuff. I'm hearing my design theory teacher's voice in my head. Something kind of like that. All right. The other nice thing about copy paste is look what happens. All of our points line up nicely. So that means that when we make a surface, the surface is going to be constructed nicely, and that will make our lives easier down the line when we fillet and blend and do all that stuff. So I just made a planar surface out of that, and I'm going to just use gumball extrude, and I'm just going to make the handle thickness about kind of what I'm looking for. And let's stick this back on the model so we can see what it looks like. That's a little heavy. Let's make it a little thinner. I'm just going to scale it in a little bit. Maybe that's even a little too heavy. Now, I've got a couple of choices here. I can make my life super easy, and I can delete this face, and I can just do a blend surface between the two. And then I can get all of my transitions and stuff for free. I like this technique a lot because it solves a lot of problems and it's super fast. And so I think I'm going to go with it instead of the more traditional, fillet, blend, all that kind of stuff. And that makes for a lovely little piece. And it's sticking up a little bit there, so I'm just going to cheat. Shh. No one will know. And I do kind of like the idea of this handle maybe getting a little bigger towards the back. And because maybe, yeah, let's do it. Let's grab and explode that. And let's go to this view, and we're going to use a bend deformer, and I'm just going to bend this surface a little bit, just to give it that little extraness. And then we can just go back and do exactly what we did before. Just blend them together. We don't need interior shapes. Notice the additional complexity because this surface got rebuilt when we put a deformer on it. So this surface is more complex, so the blend is more complex. Not a big deal, but it is something that you need to at least understand and make a note of. All right. I like that a little better. I think that looks a little nicer. So let's join all that up. And let's Boolean these things together. Now, I think I can probably get away because this is a fairly simple surface and because most importantly, we used curvature when we made this blend. So that means that this transition to here is curvature, which is going to make our life much easier if I come up here and I do a blend surface around this, and that's going to be too big. So let's set all. Still too big. So that's going to go in nicely. And we might want, let's do this. Let's make a handle here. And we're going to do this handle at 0.15, this handle at 0.15 or 0.05, and then I'm going to stick another handle here, and then let's mess around a little bit with the diameters and see what happens. So if I take this one and say 0.1, oh, I did the wrong thing. 0.1. Rhino's being kind to me and tolerating this kind of ham-fisted nonsense. Let's drag it down and see if it comes together. And if it doesn't, right, if this doesn't work, and so 0.5, 0.59, this might be a situation where actually a pipe trim makes my life easier. So I think what I'm going to do is I think I am going to just go ahead and pipe trim this because that's not entirely giving me what I want. So I'm going to join this. I'm going to pipe it. And you can see that pipe actually goes around there quite nicely. It's not causing any problems whatsoever. And so what I can do is I can trim this object with the pipe, and it should give me a nice even gap. And because of that nice even gap, I can do a nice blend. We're going to chain these edges. And it looks like it made it a little ugly right there. See that? Let's fix that. I don't love that. So let's fix it. So let's go through here. Let's do it this way. Let's clean that up just a little bit. Because the key here is the gap. The gap is what we want a nice, clean gap. And then once we have that, then the blend kind of takes care of itself. All right, see how that gap looks a lot nicer without that little weird cap in there? All right, let's chain everything. Looks like there's some little curved segments in there. So we got some weird twists, so let's add a couple of shapes in there. We're going to just go from there to there. And right kind of where the transition edges are is kind of a nice place to add the handles. And then we've got a little bit of fixing because we can see see how the blend is fighting the shape. So I'm going to hold down the Alt, and then I'm going to just break it free. And we're just going to change the orientation of that a little bit. Same thing here. See how that looks much nicer. I show this to people and they're like, wait, what? I didn't know you could do that. I've been using Rhino 20 years. I didn't know you could do that. This is massive helper. All right. I'm going to just let that do 1 and 1 and I'm going to call that good. We'll join that up. That's a nice curvature blend. Let's render it. Take a look. I'm pretty happy with that. That looks pretty nice. And then the last one we've got down here, and I am going to just be bold and say that we're going to run into the exact same problem we had before, so I'm going to just pipe it. And let's... Actually, I think I can pipe on the surfaces. I just have to chain the edges. Yeah, that lets me skip the duplicate curve thing. So that works. You can see that there's going to be a little weirdness here, but I'm okay with that. We'll fix it. Any questions so far? We're almost home here, so I appreciate your sticking with me. All right, so let's take a look and see what we've got. Looks like it made a really nice cut out of that one, but it looks like, see how that's a little fugly? Let's just fix it. Let's just go, I don't know, something like that. I think that probably is going to work just fine. All right. We're going to do the same thing here. We're going to just do that blend curve or that blend surf. And that lives under here. I keep grabbing it from my hotkeys, but it lives under here. And we're going to chain the edges. Auto chain it. And a little twisty, but that's okay. We're going to add some shapes. Don't panic. Just those edges of those locations are great. And then we'll use that alt key trick to break these loose. And I'm going to just slide that. See how those line up nicely? The surface kind of tells you where it wants this stuff to be. If you just pay attention to kind of what's happening. And if I just click in the dialog boxes, it recenters that. See how those highlights are tracking really nicely? I think this is probably the nicest one so far. Call that good. All right. Now, we should have, if we look at this, we have 3 naked edges, so we need to figure out where they are. And it looks like it's right inside of that. And the reason for that was that thing is a little messy. However, this is where I go, I could fix it, or I could just, because the other side of the model is just fine, I could just do this. And I could worry about it. And I could say, oh, boy, I sure wish I could figure out why that was doing that. And I sure wish I knew why things are the way they are. And I could care about that. but I don't. So I'm just going to take the part that's good and keep it, and I'm going to get rid of the part that's bad, and I'm going to just copy it over and call it a day. And if it really bothered me, I could say merge all coplanar faces and get rid of the center lines of the coplanar parts, but I don't really care because this thing is probably going to be either blow molded in 2 parts, and that gives me a nice parting line, or I can make all sorts of reasons why I think that's fine. But the best one is I'm lazy and I don't want to fix the other side, nor do I care why it failed. Let's make our little thing here, and I'm just going to use a cutter from Gumball. Cut that off, and that gives us our shape. Now, we have a couple of options here. The first thing, we could just call this done, right? We could say this is a blow mold, and they're going to make the tooling from this, and they're going to blow mold it, and they're going to call it a day. If I wanted to 3D print this, obviously I would have to have some interior volume on this, and shelling this would be an unholy nightmare, right? This would be something to shell. This would just be no fun in every possible way. And so what we can do is we could shell this with shrink wrap, and there's a great video on how to do this called Never Fail Shelling with Shrink Wrap. But essentially what you do is you shrink wrap the outside, and I'm not going to go through this. Actually, we do have enough time to go through this. Let me go through this real quick. So basically what you're going to do is you're going to mesh this part, because obviously something that's going to go to a 3D printer is going to be meshed anyways, right? And so what we're going to do is we are going to shrink wrap this and create a mesh. And we're going to do this, and I'm going to change this to rendered mode so we can see what it looks like. And we're going to preview this. And we're going to hide the input object, and we're going to say, wow, that looks terrible. And then what we're going to do is look at this target edge length. And what Rhino does is it gives you a basic target edge length to create a closed object. And the reason it gives you this is because it's quick. And so now what I'm going to do is I'm going to start going by halves, and instead of 0.28, I'm going to go 0.14, and then I'm going to let that regen, and it gets better, right? And I'm also not going to fill the holes on this because that's getting rid of our pattern, and I'm going to hide the mesh wires so that we can start to see what's going on. Now, 0.14 doesn't give us enough detail, so let's go to 0.07, and the detail is starting to show up. 0.035. It's getting better. Let's go 0.015. Now we're starting to get a pretty complex mesh, but it's also starting to look pretty good. And I think let's go 0.0075. And that should give us a pretty nice result. Okay, you look at those edges, looks pretty good. It's in white, it's a little bit hard to see, but it's doing okay. Now, if I turn the mesh wires back on, you can see there's a lot of meshes, a lot of things in here, and that's because we have the polygon optimization set to 10. If I take this and I bump it up to like 30, what it's going to do is it's going to throw away, in places where it's flat, it's going to get rid of polygons, and places where it's curvature, it's going to keep them. So if I bring this up to like 50, this is nice because it actually drops the polygon count a little bit, and it makes it a little bit easier to deal with. And then the last thing I want to do, I'm going to throw like, I don't know, 3 smoothing iterations on this and just let it soften just a hair. Now, keep in mind, the goal here now we've decided is going to go to 3D printing, so we wanted a shelled part, and so our output is going to be mesh. And we're going to call this good. And if we look, give it a second to finish. Thinking. There we go. So we've got 890,000 polys in this. That's a big model, but it's not insane. So I'm going to isolate and keep this. So this is just our mesh part now, right? And I'm actually going to shrink wrap this again. I'm going to shrink wrap the shrink wrap. On this one, I'm actually going to not fill holes. I'm going to preview, and I'm going to take the defaults. We're going to hide the input object, and it's going to look like that. But now I'm going to offset, and I think I'm in millimeters. I am in millimeters. Oh, I'm in millimeters. So this is a very, very tiny part. That's why everything's weird. Okay, never mind. So we're going to offset, let's offset 2 millimeters. That's too much. Let's offset 0.2 millimeters. Negative 0.2. There we go. So that brings us down. Actually, that's why everything's weird. Okay, let's fix this because that's going to make everything weird. So I'm in millimeters, so let's go. I have to bring in a ruler. Let's see. Everybody in Europe's laughing at me. Let's go. Let's call this 200 millimeters. Let's scale this to 200 millimeters. That's why this thing's so tiny. Fabulous. Let's make this less tiny. Tell me you're American without telling me you're an American. Millimeters flummoxes you. All right. That looks better. Hide the input object. All right. I was wondering why all those values seemed really bizarre. So negative 2 millimeters gives us an offset of something to that effect. We're not going to fill the holes. And let's do 3. It's going to give us better resolution. And this doesn't need to be super, super detailed for the inside. In fact, we may even want to do like a smoothing operation of like 5. That's too much. 2. Maybe we need 1.5. A few more polygons just to get a little bit more detail out of it. And that's okay. And you can see that like we're at a pretty reasonable mesh count here. And if I say okay, now I've got a mesh inside of a mesh with a wall thickness. Now, the only thing that I need to do now is I need to pop the hole through this, right? And so I'm going to do that by drawing a piece of geometry on the top of this where I want this hole to be. And then I'm going to take this and just drag that up. Oops. Drag that up. And then I'm going to hide the external one. Do a mesh boolean between this part and this part. That ends up like that. And then let's do the same thing over here. I may just draw a quick little piece here. Something like that. Oops. And so I'm going to take this and let's place this kind of like that. Get this about where we need it. And I'm just going to do a little extrusion. Out like that. Again, mesh boolean. And then we've got this plug that when we bring back the other part, it sticks through. And then all we need to do is do a mesh Boolean subtract. That's the part from. That's the part we're using. It's going to think for a second. And the cool thing about this is because shrinkwrap uses voxels, it does a really, really good job of creating, usable meshes. And we can see that now this thing is shelled out. And, that's not ideal. We'd probably do a better version of that. But you can see if I grab this and do a clipping plane. Nope. As we drag through this thing, it's nice and shelled. Okay, nice consistent wall thickness. Voxels doesn't bow tie. That's the one nice thing. So down here, you can see that it's created a nice wall thickness in that area as well. And it's good to go. So this is something that could print and would come out just fine. This should be a closed mesh. One closed mesh added to selection. So if you sent this to a printer, it would print just fine. Would you explain how the target edge and polygon optimization influence one another and the overall poly count of the size? Yes. The target edge in shrinkwrap, this is how big the polygons are. The bigger the polygons, the less detail. The smaller the polygons, the more detail. Polygon optimization is looking for flat areas where it can get rid of polygons. So it's essentially a flat plane decimator. And so the more flat areas it can find, it will combine triangles into quads into bigger quads and stuff like that until it starts losing the ability to be able to get the curvature that it needs. And then the smoothing operations, because it's voxels and voxels are kind of cube shaped, what it does is it looks for areas of high curvature and it puts smaller cubes in those areas to make for a smoother area. So if you've got a lot of detail and you're starting to see jaggedy artifacts and stuff like that, put a smoothing operation or 2 or 3 on it. Go easy. This tops out, I think, at about 5 or maybe 10, but 1 or 2 is usually plenty. And then the target edge length, it's really, really easy to make a model that's just massively, massively massive and destroys your computer because it melts down because it doesn't have enough CPU to handle it. So that's why I use half. So whatever it gives you, start going down by half. And then once you get closer to what you want, sneak up on it so that you don't end up, if you just go from the recommendation and you say it gives you 7 and you go to 0.001, it's just going to bury the machine for an hour. So that's why I like to sneak up on it a little bit at a time. Okay. And then fill holes. I usually shut that off when I'm trying to mesh a model because that'll mush over details. Okay. All right, so I think that's about it. And I think if we were to bring this to its parity size, we can do this and say, like that. So we can start there. All right, so that's how you can go from, fully nice clean CAD. This will data transfer all day long. SolidWorks, UG, Pro E, all that kind of stuff. This goes to a printer shelled with wall thickness and all that stuff. So pay attention to areas inside like this. Just make sure that when you do the smoothing and stuff, you don't over smooth inside corners because you can make them thin. I think actually when I was showing the clipping plane, if we're going to be completely transparent here, I think I over smoothed it a little bit in that area and it got thin. Let's take a look. And the fix is to just give it, yeah, see how it got thin right there? So I didn't give it quite enough resolution to get down into that corner. So I should have lowered the target polygon count, or lowered the target edge length enough so that it added a few more points in here. So just pay attention to that kind of stuff. And this clipping plane exercise is a good thing to do. So when this printed, that inside corner right there would be a little bit too thin. So I would need to pay attention to that. So I'd probably go back if I was going to do this and remake the plug. I'd either offset it a little bit more, or I'd add smaller target edge length so that it would suck down into this corner a little bit more. The other ones look okay. That one's thinner, but okay. That one's okay. Thinner, but okay. This one got a little bit too thin. So you can even see that it's got a little hole in it. So I would probably offset a little bit more. To split the object, you use split or Boolean split. I used Boolean subtract, actually, this one. And you have to use the mesh ones. So this one, Boolean subtract, or Boolean difference. Okay. And then if you wanted to split this in half, you could just split it with a plane. And then there is a video on YouTube called How to Make Lap Joints and stuff. So if you wanted to make lap joints on this, you can take a look at that. Same process, but you just offset one more time and create a plug that you use to add to one and take away from the other, and you end up with a lap joint. So all of this stuff is going to end up on YouTube. Rhinoceros 3D on YouTube is the place where all this stuff goes. And I appreciate your time. I think that's all I have for you. If there's any other questions. If not, I will let you go. My name's Kyle Houchins. This was Getting Started Rhino for Windows. Go make great stuff. Thanks for watching. Bye.